All right, so if we find the value of the determinant, starting with this first one, we start in the upper left-hand corner. So I'm going to start with 4 up here. We're going to multiply diagonally to the lower right-hand corner to 7. I actually write out the steps as we're getting used to this. 4 times 7. We're going to subtract then, well, the product for the other diagonal. For the other diagonal, we're taking -3. We're multiplying to 6. So not that it's necessary to write out all this work, but since we're getting used to the idea, you can see all the pieces involved. If I do these calculations, I've got 28, double negative here, so plus 18. The value for this determinant is going to be 46. So that's how it works with numbers. Throw some variables in there. It's not going to change the approach. Start in the upper left-hand corner again. This time, we've got k involved. We're going to take k. We're going to multiply down to k minus 1. Now, as I multiply that, definitely want to write out this step because k minus 1 is a quantity. I'll need to distribute that k through. I'll be subtracting from that the product for the other diagonal. So for the other diagonal, I'll take 5 times that quantity of k plus 2. So again, I need parentheses here because I'll distribute that 5 through. As I do my distribution, again, this equals this step here. This equals the next step. Distribution with the k. I've got k times k, so k squared. I've got k times -1, so minus k. Distribution with the -5, I've got minus 5k. -5 times 2 here, get minus 10. That's going to equal, well, k squared minus 6k, combining like terms, minus 10. That's the expression that represents the value for that determinant. Okay, if we're going to solve a system using Cramer's rule involves applying these determinants. Okay, it actually involves, for both x and y in these systems, a ratio of a couple of determinants. So what we have to do first is we first have to make sure that each of the equations is in standard form, which this one is. And then what we're going to do is we're going to set up what I call the denominator determinant. So we're going to set up the denominator determinant, and what that's going to involve, in the first column, it's going to involve the coefficients on my x's. Remember, I'm trying to come up with a square arrangement over here. So I'll need a couple of columns, both with 2 values in there. So the coefficients on x create the first column. For the second column, we're going to take the coefficients on the y's. So -1 is the coefficient up here, 3 is the coefficient down here. Now let's go ahead and evaluate that because it's going to be useful for us to do so. If I evaluate that, cross product here is 6, minus cross product here is 1 times -1, so -1. We're going to get 7 back, right? So our denominator determinant that we need to use here, we got a value of 7. Now we can put it in its place. Okay, now how we go about figuring out x and y? Well, let's start with x. To figure out x, I mentioned how x and y, we're going to use a ratio of 2 determinants to help us figure out x and y. The denominator, we already know in this ratio, it's going to be 7. Now how we set up the numerator. The numerator is going to be a determinant. And basically we're going to use, for guidance, our denominator determinant right here. See, this 2 and this 1, they were the coefficients on x, right? And this -1 and 3, they were the coefficients on y. So since we are solving for x, how we're going to set up our determinant over here, in this first column, where I had 2 and 1 on the denominator one, I'm actually going to take these constant values and I'm going to put those in the first column. So what I'm solving for here, that respective column over here for that variable gets replaced with these constant values. And then the other column stays the same. So the other column represented the y's, they stay there. Okay, that's how I'm going to set up and solve for x. Now, as long as I'm talking about setting things up, so you can see the pattern here, let's go ahead and figure out the y side. On the y side, again, we know it's a ratio of two determinants. Denominator is going to be 7 that we found originally. Setting up your determinant for the numerator. Okay, now I'm solving for y. Going back, using this denominator determinant again for guidance, I'm going to keep the first column as 2 and 1 because that was connected to the x's, so that stays the same. But since the second column came from taking the coefficients on the y, I'm going to replace that column with those constant values of 10 and -9. So you can see how the constants are being applied over here. The constants are being applied over here. They're just taking the place of the column that represents that variable you're solving for. So now if we do our calculations, over here for x, well, let's see. If I multiply across, I get 30 here, minus multiply across, I get 9 here. That's all over 7. So x is going to equal 21 over 7. X is going to equal 3. And for y, if I do my cross product for 2 and -9, I get -18. I'm subtracting. Multiply 1 and 10, so that's 10. That's all over 7. We'd have -28 over 7, so y is -4. This is still a solution to a system. It's just using a new method. So we need to, at some stage here, create our ordered pair that represents that solution. So here's our ordered pair. X is 3, y is -4. All right, so if we solve this system using Cramer's rule, again, you got to make sure these are set up correctly. So you need the standard form. This first equation, we got all these fractions floating around, not standard form. Be nice to clear those fractions out. So I'd make an adjustment. I would take this first equation. I would multiply all of it. Now let's see, what would it make sense to multiply by? 12? Yeah, if you multiply by 12, that's going to help you clean up these fractions pretty nicely. So we multiply everything by 12. In doing so, we're clearing out the fractions. So as I distribute 12 through over here, 3 goes into 12 4 times. You got 4 times -2, so -8x. Plus, 4 goes into 12 3 times. 3 times 1y, get 3y. Equals, over here, 2 goes into 12 6 times. 6 times -1, get -6 back. So we've adjusted the top equation. The bottom equation is going to stay the same. You should notice something interesting happening here. Right? I mean, think about the other methods that you know to solve these, right? Something interesting should happen here when we solve. So let's take that denominator determinant that we set up first on the last problem. Figure out what that's going to be. The denominator determinant involves the first column where we're taking the coefficients on the x's, so it's -8 and 8. And the second column where we got coefficients on the y, so 3 and -3. We evaluate that. Cross multiply, got -8 times -3, get 24, minus, cross multiply here, 8 times 3, 24, we're going to get 0 back, right? Now keep in mind how we're going to use this. To solve for x, to solve for y, we'd have another determinant that would be over this denominator determinant on each, and that denominator is going to be 0. So is that possible? Of course it's not possible. since it's not possible, it should make sense then that this denominator came out to be 0, so there is no solution. And if we had to classify the system, just to review, that would be an inconsistent system.